When you look at the map of the world, the oceans and seas are easily identifiable and you might think that they just flow into each other. It seems like there's only one large ocean which has been given different names by the people living around the different parts of this large ocean. Well, this is not the case. In fact, the borders between the world's 5 oceans are tremendously vivid. You will be amazed to know that despite being made entirely of the same components, H2O, water bodies do not always mix. If you ever get to have a look at the point where the world's 2 largest oceans, Pacific Ocean and Atlantic Ocean meet, a very strange phenomenon occurs. The waters of the Atlantic and Pacific Ocean refuses to mix. What is even more spectacular is that the border between these 2 oceans is like a line between 2 worlds. The darker Pacific waters stands next to the lighter Atlantic waters, and it looks absolutely astonishing as this boundary continues for up to 800 kilometers, which is known as the Drake Passage. So, why this happens? The thing is that water can be different too. The Atlantic and Pacific Oceans have different density and chemical makeup, the level of salinity and other qualities, and this is what forms a barrier between them, making it difficult for them to mix. One can easily make out by the difference in colors that water of the 2 oceans are far from being the same. When 2 bodies of water with significantly different salinity come together, a halocline is formed as the bodies of water refuse to mix, which is spectacular, and this is what we see when Atlantic and Pacific Oceans meet. Haloclines appear when water in one ocean or sea is at least 5 times saltier than in the other. Now, you might argue that as per basic physics laws, a denser liquid should end up lower and less dense liquid higher. As per this theory, we should have the water from the Pacific Ocean flow on top of the Atlantic Ocean. The border between the 2 oceans would look not like a vertical line but as a horizontal line. But clearly this is not the case. So, why does this not happen? The answer to this is a combination of 2 effects. First, the difference in the density between the water from the Atlantic Ocean and that of the Pacific Ocean is not that great for one of them to get down and other to rise up. However, it's sufficient to prevent them from mixing. The second reason is inertia, one of the inertial forces known as Coriolis force. It influences the movement of the object. One of the example of the effect of Coriolis force is seen on the rotation of the Earth. As the Earth rotates, all the moving objects on the Earth are acted upon by the Coriolis force, deviating from their course. As a result, the object on the Earth's surface don't move in a straight line, but deviates in the clockwise direction in the northern hemisphere and anti-clockwise in the southern hemisphere. Because of this, the direction of the flow of water bodies in the Atlantic and Pacific Oceans are different. It also doesn't let them mix. Another important difference between the 2 oceans' water is the strength of molecules connection or surface tensile strength. The 2 oceans have a totally different surface tensile strength, and it also doesn't let them mix. Thanks for watching, and don't forget to subscribe and smash the like button. If you have more interesting ideas, don't forget to leave them below.